All right, so first of all, sorry I forgot to bring my headset home, so I'm using the microphone on the laptop. Hope you can hear this. This is just a quick tutorial to show you, if you've not done this before, how to set up your data and produce a plot in Excel for the Beer's Law plot that we're going to use for the concentrations of the standards for the manganese and steel. Now this goes with the second part where we measured our samples using the atomic absorption spectrophotometer. I have put in the concentrations in parts per million, which is milligrams per liter, of the standards that we use. So we used a water blank that would have 0 parts per million, and then the 1 through 5 parts per million. These were the absorbances that we obtained from the spectrophotometer. So hopefully everybody got a copy of the printout that has it on it, but they're provided here. Now, just to show you a couple of things that you might find useful. First of all, we know that these had a higher degree of precision than we're showing here. So to quickly reflect that, since we're trying to produce a report quality plot, if I look on here, I can highlight these, and then if I come up here under number, I can increase or decrease the decimal very quickly with a click. I'm going to increase it out to my level of precision, 3 decimal places. Notice my absorbances also have varying degrees, so I'm just going to increase them all, get them all out to that 4 decimal places. All right, now there's a couple of different ways that we can calculate this, but what we want is the full equation that describes the relationship between absorbance and concentration. We want to create a line, we want to get the slope of that line, the equation that describes it, because that is what will allow us to calculate our concentration. So in order to create a plot, what I'm going to do, first of all, you always need to make sure that whatever you want on the x-axis of your plot is in the first column of Excel. I want concentration to be on the x-axis, therefore it's in column A. Absorbance goes on the y. Now what I'm going to do is just pick up all of my data and highlight it. You can pick up just the values. So what I've clicked, I click and hold and then scroll over those. I'm going to go ahead and pick up the titles here. If this works correctly, what it should do is put those in already as part of the legend as my relationships there, as my axes. All right, so that's the data I want to plot, and then I can, a couple of different ways to do it, but I can come up here to insert. All right, there's different kinds of charts, and what I want is XY, scatter XY or bubble chart. And when I click on the choices, what I'm going to do is just choose the first one, the scatter that has just the data points, because I want to put in my own trend line. I don't want to connect the dots. So here's my chart, and you can see they've titled it absorbance, so that doesn't always work. I'm going to change that title to read something that's more appropriate. It could be calibration plot, Beer's Law plot. I'm going to call it calibration of manganese in steel. All right, and I can go back and put in X and Y axis titles as well. To do that, what I'm going to do is hover over the axis and then right click. Use your right mouse button. You should get a pop-up menu. Okay, anytime you've got an Excel plot, you can always right click on something you want to change, and you should get a pop-up menu that relates to that. So for example, if I want to format the axis, okay, tick marks, labels, label position next to the axis, high, low, none. Okay, that's where I want to put that. And let's see, oh, that one's not putting it in there. So we're going to have to come up here. Let's see, format, no, I was there under design. Add a chart element, and I want to add axis titles. Okay, so there's my horizontal and primary vertical. I'm going to go ahead and put it that way. So on the Y, we said that that was absorbance. And on the X, we have concentration, and that is in parts per million. Notice absorbance doesn't have a unit. It's an arbitrary unit. All right, so I've cleaned it up a little bit, but what I want to do now is figure out what is the equation that describes this line. So I'm going to choose any one of them, doesn't matter which one. I'm going to hover the mouse over one of those points and right click. I get my pop-up menu, and I'm going down to add trend line. Click on that, Let's see. And the other thing, okay, I want to format that trend line as well. It didn't, oh, okay, it's giving it to me over here. I'm sorry, this is a slightly different version than I'm used to using. It's different from home and work. So if I look over here at format trend line, it's giving me some choices. Linear, that's what we want to use. We're looking for a linear relationship. That's what we're presuming it is. And automatic, that's fine. Forecast, we don't need to do that. We don't need to worry about setting the intercept because we started at 0, 0. We zeroed our instrument. What we do want to do is display the equation on the chart. So there's the equation right there. Y is equal to mx plus b, where y is absorbance, x is concentration, slope and intercept. Okay, this is the relationship. So now if I want to calculate concentration, which is x, I can plug in the absorbance that I measured, y, solve for x. Now the other thing I want to do is come back down here. I want to display the r squared value on the chart. That tells me something about how linear my chart is. How much precision do I have from the values that I measured? Now, you'll read in a lot of different places for general chemistry, they'll say that an R squared of anything over 0.95 is good. It tells you it's good, 0.99 is good. For what we're doing for precise analytical work, really you want that third decimal place to be as high as possible. So in reality, this 0.991 is actually not a very good fit. So we probably, we have to take this data with a grain of salt. But if we look at it, we've got a pretty obvious outlier here. Now, we could run it through a t-test. We could look at, how believable is that point? Is it truly an outlier? We did those calculations to look for outliers. But in the interest of keeping this moving, I can tell you that if we look, the relationship here, it should go up about 0.05 each time. 0.4, 0.8, 0.12, they seem to be following along pretty well. But then this one, 0.16 and then 0.20, these kind of fall short, this one especially. So our 4 part per million solution probably had an issue. There was something wrong with that one. If we look, the rest of the points are pretty close to the line that we described. That one is off the line. So I'm going to tell you it's an outlier. Okay, we're going to throw that one out as an outlier. Now we see our R squared goes up to 0.998. That's better. Ideally, I would have really liked it to be 0.999, but we can live with 0.998. All right, so now this is the equation. Y equals 0.039x plus 0.0032. That is what is going to allow you then to calculate the concentration that you had in your sample. So if you want to continue doing that on your Excel worksheet, what you can do is put in the absorbances that you measured, and I'm just going to make up some numbers here. Okay, whatever they were, you can put those absorbances in, and then you can set up a formula over here. Okay, so this was y equals mx plus b, but remember, we have y, we have the absorbance, we need to solve for x. Okay, so the formula for x is going to be equal to whatever y is, the absorbance, okay, minus 0.0032. We subtract it from both sides to get the x value by itself. And then the other thing we have to do to get x by itself is divide by that term, so 0.039. That will allow you to relate those two. Okay. I can copy that formula down, and notice you've got way too many significant figures in there, so you can reduce those down. Really won't matter because that's not your final number. This is the concentration in your sample in parts per million. Now, I will tell you we had a little issue. We were translating directly from that parts per million into weight percent. We did, and I apologize, I missed this one. We weren't quite thinking clearly. That is the concentration in parts per million of manganese simply in the standard that you made, which was the 200 milliliter solution. So what you really need to do is figure out if you had 200 milliliters of solution, this is the number of milligrams of manganese in a liter of solution. So if you only had 200 milliliters of solution, how many milligrams of manganese did you have? Then if you divide that by the mass of your original sample, that will, and then multiply by 100 for percent, that will give you the weight percent in your original sample. So we were doing a little bit of incorrect calculating there. So from there, you can calculate back to your weight percent and continue on with data analysis.